Hey, we're here for the first lesson in Unit 3. Today we're going to do a little bit of review talking about slopes of lines and the equations of lines, and this will kind of set us up for the unit, which is kind of a short unit talking about parallel lines. So the first thing we need to know is what slope is, and slope is the slant of a line. And sorry, I'm trying to get my pen going here. And if we look at this line over here, and we want to describe how slanted it is, we're going to be talking about the slope of the line. So one thing we can do is find 2 points on the line, which I made here kind of big so that it stands out. And we can determine how far apart these 2 points are vertically, which we call the rise. So if I start at one point, I usually start at the leftmost point. So I'm going to see how far I have to count up to get as high as the next one. So I count up 1, 2. So I'll show that 1, 2. The pen's a little bit big. We'll make it not so thick. So I'm going to count up 1, 2. That's my rise. And then I'll count over. I'll start at the leftmost point. 1, 2, 3, 4, 5, 6, 7, 8. That's my run. Since I went up, up is positive, down is negative. And I went to the right, right is positive, to the left is negative. And I can simplify this to be 1 over 4. So the slope of that line over there is 1 over 4. That means for every unit I go up 1 and I go over 4. So I can even start at this point again, go up 1 and then over 4. 1, 2, 3, 4, and I'm back on the line. So hopefully this was review. Another way to find slope is to use the slope formula. Slope is represented with the letter m. And if we have 2 points in the coordinate plane, x1, y1, and x2, y2, so go back to distance formula and midpoint formula. Those are points in the coordinate plane. We find the difference in the y's, that's the rise. The difference in the x's is the run, and that gives us slope. So let me show you an example. If I want to find the slope between these 2 points, I'll start like I did with distance formula or midpoint, and I'll label one x1, y1, label the other x2, y2, and then I can rewrite the formula always. And then I can plug in what I know. So this becomes, like we used to say, a plug and chug problem. So y2 was 0 minus y1, which was negative 2. x2 is 10 minus x1, which is 3. This becomes positive 2 over 7, and that's my slope. So pause the video here. I want you to find 2 different slopes. Find the slope of the graph at the right, and then find the slope that goes to those 2 points. So if I want to find the slope here, I always start at the leftmost point. You can start at the right point if you'd like. I'm going to count down till I get to the same level as this point. So I'm going to count down 1, 2, 3, 4, 5, 6, 7, 8. So that is my rise is negative 8 because I went down. Then I count to the right 1, 2, 3, 4. That's a positive 4 because I went to the right. And I can simplify this. Negative 8 divided by 4 is negative 2. And I can say negative 2 over 1. So that tells me every time I go down 2 and go to the right 1, I'll end up back on the line. So I can start on this point, go down 2, to the right 1, and I'm back on the line. And I can keep going. Down 2, to the right 1, down 2, to the right 1. I think you get the picture. Over here, I can use my slope formula because I have the coordinates of the 2 points. y2 minus y1 over x2 minus x1. And the easiest way to make a mistake here is to put the x's on top and the y's on bottom. So it's rise over run, y over x. And I label my points x1, y1, x2, y2. And plug in. So y2 is 13 minus negative 7. And you can see there I made a mistake. It's easy to make. I need to plug in 8, not negative 7. So you should double check your work when you're doing things like this. And my x2 is 9 minus negative 7. Now we have it in the right spot. So I end up with 5 on top. 9 minus negative 7 gives me a positive 16. And I can't really simplify that fraction, so my slope of the line that goes through those 2 points is 5 over 16. Another thing that should be reviewed here is slope-intercept form. Remember that slope, we use the letter m. So if I have an equation of a line in slope-intercept form, I'm going to have m times x, so the slope times x, plus b. And b is the y-intercept. And the y-intercept is where the graph of our line crosses the y-axis. So if I look at these two equations, the slope of my line is the number in front of x. So 1/2 is a number. So my slope is 1/2. And my y-intercept is always the thing that we're adding or subtracting from that slope times x. So my y-intercept b here is positive 6, which gives me a coordinate of my y-intercept of 0, 6. So the graph of that equation looks like this. Y-intercept at 6. So the line crosses the y-axis at 6. And it has a slope of up 1 over 2. So 1 up, 2 to the right, which is actually the same as down 1, 2 to the left. So I can draw my line like that. And again, this should be reviewed. If I get an equation in this form, it's not in slope-intercept form because y is not all by itself. So if we want it in slope-intercept form, we have to solve for y. So I can do that by subtracting 3x. I get 2y equals negative 3x minus 11. Remember, we can't combine those things. Divide everything by 2, so I divide every term by 2. And I get my equation to be negative 3 over 2x minus 11 over 2. So my slope is the number in front of x. My slope is negative 3 over 2. My b is negative 11 over 2, which means the coordinate of my y-intercept is 0, negative 11 over 2. Negative 11 over 2 is the same as negative 5.5. So if I want to graph this, my line crosses at negative 5.5, and the slope is down 3 to the right 2, which we said we can go the opposite direction. So down 3 to the right 2 is the same as up 3, 1, 2, 3, to the left 2. And there's my line. It's a little sloppily drawn. You should use a straight edge. And remember, if my line goes up to the right, it should have a positive slope, which it does, positive 1/2. If it goes down to the right, it has a negative slope, which this one does, negative 3 over 2. So pause the video here, take a minute, and find the slope and y-intercept of each of these lines. The first one's kind of easy. The slope is the number in front of x because y is all by itself. We're in slope-intercept form. So the slope is 3. My b value is negative 5. That means I have a y-intercept of 0. negative 5. Over here, I have to solve for y, so I'll subtract 2x. That negative belongs with the 8y. I like to write my negative 2x first because it looks like slope-intercept form. Now I divide everything by negative 8. Every piece gets divided by negative 8. So I end up with a slope here of negative 2 over negative 8, which is the same as positive 1 over 4. I just canceled out these negatives and I simplified. My b value is negative 3 over 2. 12 over negative 8 is the same as negative 3 over 2. So my coordinate for the y-intercept is 0, negative 3 over 2. I put in a reminder here that horizontal lines have a slope of 0. Horizontal means going straight from left to right or right to left. And they always have an equation of that line in the form of y equals. Vertical lines have undefined slope, or sometimes we say they have no slope. And the equations always have the form x equals. So let's look at these examples over here to the right. If we wanted to write their equations, this one right here is a horizontal line. That means it has 0 slope. And it has the equation y equals, and we go and see where it crosses the y-axis. It crosses at 2. So the equation of that line is y equals 2. Because every point on this line is going to have a y value of 2. So y is always equal to 2. For the vertical line, I have an equation in the form x equals, and I do the same thing. I go look where it crosses the x-axis. It crosses at 2, so it has the equation x equals 2. And that's because every point on this line is going to have an x value of the coordinate that's equal to 2. So any coordinate I write that's on this line is going to have an x value of 2. And again, I'm hoping this is kind of review from algebra. So I want you to try these two problems on your own and be prepared to ask any questions in class. And I will go over these two problems at the beginning of next class.